P0172 on this Ram 1500 Classic with the 3.6 Pentastar is a fuel system 1/1 rich code. In plain terms, the PCM may be seeing a mixture that looks too rich and may be pulling fuel correction back to compensate. The driver may see the MIL, and on trucks equipped with stop/start, that feature can be disabled while the code is active. Possible fault areas can include fuel delivery, injector leakage, purge flow, air or exhaust restriction, MAP input, oxygen sensor wiring or sensor operation, engine mechanical issues, and only after the diagnostic path supports it, the PCM. The fuel target is based around 14.7.1. For this fault, when the combined short-term and long-term correction drops less than a calibrated threshold, generally 67%, with 100% nominal, the fail timer increments. After 30 seconds of fail time, the diagnostic fails. Before chasing the rich code, start with the basic system checks. Then start the engine and reproduce the operating conditions that allow this monitor to run. Treat the running conditions as a monitor gate. Closed-loop fuel control with the engine running, battery voltage above 11.0 volts, barometric pressure greater than 75 kPa, ambient temperature above -7 degrees C, 20 degrees F, fuel level greater than 12%, and altitude below 2,590. 8M, 8,500 FT. Use the scan tool to read and record the codes. It may take a road test, and the best path is to repeat the captured conditions from when the fault originally set. If P0172 is active or pending, continue the diagnostic. If it is not active or pending, handle it as an intermittent condition rather than forcing a hard fault diagnosis. Next, look at the recorded codes. If other fuel or air handling faults are active or pending, diagnose those first, because this rich code can be set by a bad oxygen sensor signal or wiring, but it is more commonly driven by a mechanical, fuel, or air handling problem. If there are no other active or pending fuel or air handling faults, continue with the P0172 path. Now check the exhaust system for restriction. Start the engine, confirm good exhaust flow at the tailpipe, and visually inspect the exhaust for damage that could create a restriction. If you find a problem, make the appropriate repair and verify the repair. If the exhaust checks out, move to MAP sensor operation. Run the MAP sensor operation check. If that check finds a problem, repair it and verify. If it does not, keep moving in order. With the ignition off, disconnect the hoses at the purge solenoid. Apply 5.0 in Hg to the engine side of the purge solenoid with a hand vacuum pump. The solenoid should hold vacuum for a minimum of 15 seconds. If it holds, reconnect the vacuum hoses before continuing and go to the fuel delivery check. If it does not hold, first verify good pin-to-terminal contact at the evap purge solenoid and PCM connectors. If the connectors are okay, replace the purge solenoid, then verify the repair. Next, check the fuel delivery system. If that test finds a fuel delivery problem, make the appropriate repair and verify. If fuel delivery checks good, inspect the engine mechanical side. The air induction system must be free of restriction, valve timing and compression must be within specifications, and the fuel must be free of contamination. If an injector is suspected of leaking or having an abnormal spray pattern, remove the fuel rail with the injectors intact, energize the fuel pump to maintain rail pressure, and check for leakage before actuating the suspect injector. Then actuate the suspect injector with the scan tool, inspect the spray pattern, and compare it with the others. If you find a mechanical or injector-related problem, repair as necessary and verify. If no engine mechanical problem is found, continue to the oxygen sensor circuit checks. For the upstream oxygen sensor wiring check, disconnect the upstream O2 sensor connector and the PCM C2 connector. Do not probe the PCM harness connectors. Probing those connectors can damage the PCM terminals and create poor terminal-to-pin contact. Use the GPEC diagnostic adapter 10436 For the diagnosis, check the upstream O2 sensor circuits between the sensor connector and PCM-C2 for a short to ground and for an open or high resistance. If a wiring problem is found, repair it and verify. If the wiring checks good, run the oxygen sensor operation check. If that finds a problem, repair as necessary and verify. If it does not, move to the related harness connection inspection. At this point, disconnect all PCM harness connectors, all related inline connectors if equipped, and the related component connectors. Inspect the harness and component connectors, including male and female terminals, for poor installation, damaged locks, corrosion, water intrusion, whether seal damage if equipped, bent terminals, signs of overheating, push-back terminals, spread terminals, and poor terminal tension. Repair any conditions found, then reconnect the PCM connectors, inline connectors if equipped, and related component connectors, making sure every connector is fully seated and every lock is engaged. Erase the codes, operate or road test the truck under the monitor conditions and read the codes again. If P0172 returns after this path, replace and program the PCM, then verify the repair. If P0172 does not return, treat the poor connection repair as the fix and verify the code stays gone. Keep verification separate from the testing steps. Anytime the path leads to a repair, clear the DTCs, run the truck under the conditions that allow the monitor to complete, and confirm P0172 stays gone. The takeaway is simple. Prove the rich condition is active, rule out related fuel and air handling faults, then work through exhaust flow, MAP input, purge leakage, fuel delivery, mechanical condition, injector behavior, oxygen sensor wiring, oxygen sensor operation, and connector integrity before condemning the PCM. For more diagnostic training, visit stepdiagnostics.com.